So I'm going to talk through the worksheets and kind of the solution that's been provided. If you look here, you can see the file structure as the students will, or as the teachers will download it. This is the kind of the data that's under the For Teachers tab. And so I'm working from these notebooks here, and I'll talk through each of the solutions. I'll just quickly flag the data with you. We'll primarily be working with Pride and Prejudice, and in the case of each text, we have the full text as a .text file, and then for worksheet 3, we'll be using the JSON files as well, which has some metadata on the characters in the text, as Marie has discussed already. So I'll just kind of talk through the code and hopefully make things a little bit clearer. In a lot of cases, there's more than one way to sort of solve the tasks. I'm not going to discuss all of them, but I'll talk through the solution that we provided. So right off the bat, the first bit of code that's already given to the students in the worksheet is just to import some relevant packages. Here we have a package for regular expressions and a package for plotting, and then setting up the data pack. So the first task for students is to read the entire novel into a list of lines of text and display the total number of lines in the novel. So if I split this here, we can see, so this is just some code to set up the path for the full text. So in the directory for Pride and Prejudice, we're looking at this full text.txt file. And the important function here for opening the file is this open. So open takes 2 arguments. The first is the path for the file you want to open. In this case, it's the novel full text path. And then there's the mode that we want to open the file in. So in this case, we're going to open it in a read mode. And then there's some additional keyword arguments to specify the encoding. So here we're using the UTF-8. So if I open this file, we see what we're dealing with is a text.io wrapper object. This is a little bit kind of dense and impenetrable, but there's a lot of nice methods defined on this object, which will allow us to read it. So typically, this is our in file, so we're going to call it fin. And then what we can do with that file is we can read it. And see, if we read that file, what is returned is just a single piece of text, which is all of the text in the file as one string. So if I call that text, for example, and then good practice would be to close that file. So if we look within there now, I can print the type of that text file. And I can print the length of that text file. And so what we'll see is text is a string, and this is the total number of characters in the text. So another approach we might want to take then, so we're looking at each line in the file. So we can split that text file into lines. There's a method defined on strings in Python called split lines. So if we call text.splitlines, and then in the same way, I'd like to check the type of my lines object and the length of my lines object. And now we can see instead of a string that's really long, we're dealing with a list, and each object is an individual line in our text. So if I show you the lines file there, now what we have is a list of every line in the text. So instead of opening and closing the file, the syntax that's used in the solution is this syntax here, with. So basically, we're opening the file and storing the output in this fin. And then we've indentation. When we leave the scope of this indentation, it closes the file automatically. And that's the reason for this syntax. So if I run that syntax, you can see the novel has, and we're just checking the length of lines. So we've open the text object, or open the file object, reading it into this text variable, and then splitting it into its individual lines. The next task is for, we'd like to work out how many of the lines are non-empty. So our lines object, again, is a list of every line in the file. And as a list, we can iterate over it. So for line in lines, we can then quickly print the line, just to show you that we're getting each individual line in the file just as a string. So similarly, I can check the length of those lines. So this is how many characters are in each line. So those lines with 0 characters are empty, and we'd like to exclude them. So if you look at the solution we've provided, we're setting up a counter object. This is just an integer to count how many of those lines are not empty. We're using the strip method on strings here. I'll just quickly show you how a bit about the strip method. So if I define a string, called my string, and I'll include some preceding and trailing white space in that string. Now, if we look at my string, we can see it's got this preceding and trailing white space. If I call the strip method on that string, that preceding and trailing white space has been removed. So that's the reason for this strip. So for each line, we're going to strip the line and then check the length. If the length is greater than 0, if the line is non-empty, then we'll just increase our counter. And that'll allow us to count the number of lines as well. So the novel has 10,000 non-empty lines. The next part is about stripping the lines in according to their chapters. So I'm going to move and the way we're going to do this is using regular expressions. There are a couple of other ways to do this, but I think regular expressions are probably the kind of the most robust way of doing it. And so a resource I like to use when I'm working with regular expressions is this regexer. I can find otherwise they can be a little bit impenetrable. So I'll just remove some of this and I'll show you quickly how we're going to work with regexer. So if I open the full text of the file, I can just grab some sample text here. You can place it into regexer. And then up here, I can define my regular expression and it will show me where that expression is matching in the text. And so we'd like to match all of these chapter statements, chapter 1, chapter 2, chapter 3. And so if I write chapter as my expression, then I'll catch that chapter part of the chapter pattern. But I like to include the space as well, and then I can include the 1. And now you can see I will match on chapter 1, but I won't match on chapter 2. So we can use these square brackets to define kind of an any operation. So we can say any of 1 or 2. So this won't, it looks like it'll match on 12. It won't match on 12. It'll match on 1 or 2. And we can define a broader range there. So we can say 0 to 9. And now it'll match on chapter 7, chapter 1, chapter 2. But it won't match, unfortunately, on chapter 12. And that's where we'll use the plus symbol. So if you see highlighting here, the plus symbol will match 1 or more of the preceding tokens. So I just wanted to highlight this. I find regular expressions can be a little bit impenetrable sometimes. I wanted to highlight this as a resource for getting a very visual kind of environment to play around with your regular expressions and see what's working. So the last thing here is we know now that this expression should match the kind of chapter strings that we want to catch as we move through the text. But we might like, when we've matched on a chapter, to know what the chapter number is. And that's why we use this capture group. So if I group the area where the number will occur in these like normal parentheses or brackets, then I'll be able to go back after the fact and query what specifically was the pattern that was matched in this area. And I'll show you how that works. So I'm just going to copy this pattern and move back into the notebook. So the way we can define a regular expression pattern in Python is using the re module or the re package. And I'll compile. So there's the compile function, and then I'll just use that pattern. So this is how we define a pattern of a regular expression that we'd like to search for in some text. So now if I have a line of text, let's start with the first line of text, which is chapter 1. Then we can see that I can call the match method on my pattern, and I'll pass the line that I'm trying to match. So it's looking for the pattern in this line. So we're looking for the regular expression in whatever string I'm passing here. And if you see, we'll call the output of this match, and we'll check what the match object is. So here it's an instance of a match object. If the pattern does not match, then there's no return. It's a none is the return, which means we can check the result of our match. So we're checking for a none type or for something that's not none. So we can say if match. So this is in the event that we found the pattern in the string. What would we like to do? So in this case, I'll just print match. Otherwise, we will we could just print no match. So this is just to give an example of how this is working. Chapter 1 does not match, but chapter 1 will match. And if we have just another piece of text, any old string, again, we would expect no match. So in the case that we'd like to query, well, what chapter did we match on? So here we've matched on chapter 23, but we'd like to know, well, what is chapter 23? Or sorry, which chapter is it? We've grouped that in the capture group. And the way we can access capture groups within a match is using the group successor method. So match.groups. I'll print that. We've only included one group, one set of normal parentheses in our regular expression. And so this should return just a list with one element in it, or it's actually a tuple with one element in it, and that element is 23, which is the thing we're looking for. So we know it's going to be the first element in the match groups. So we can ask for the 0th element in the match groups, and we'll see that we've matched and that the match was on 23. So now you can see as we're moving through the lines in the file, we're able to query, is this the beginning of the next chapter, and what number chapter is it? And so then as we move through, we'd like to save those lines to specific lists based on which chapter we're looking at. So I'll quickly show you the kind of the structure that we're looking for our output here. We want a list for each chapter, so we can use a dictionary. So we'll define, it'll be comment this, it'll be sort of chapter lines where it's a dictionary, and the keys will be some chapter's number. Chapter num, and the value will be a list of lines. So these are all of the lines in that number, or in that chapter, and then we will have some other chapter, and the corresponding lines. Okay, so that's those are kind of the pieces of this large chunk of code here. So I'll talk through that now. And this is nicely commented, so I hope it'll be okay. But essentially, we're defining the expression. It's the same expression I've already showed you. We're working. We're then defining an empty dictionary, which will be, these are the lists of all our chapter lines, and we want to store our current chapter number, and we'll start at 0. So for each line in the file, check if the line is empty. If it's empty, we'll ignore it. So continue, we'll just ignore all of this and move to the next iteration. And then we'll check for a match. If we do have a match, we'd like to get the string that matched in the group, which is the chapter number itself. We'll convert it to an integer, and then we'll add an empty list for this new chapter into our chapter lines dictionary. And then we'll move on to adding the current line to the list, which corresponds to the current chapter number. And so if I run that code here, we'll see at the end, we'll just print the last value of current chapter number as the number of novels in our chapter. So let's take a look at the chapter lines object. So here's chapter lines, and we can see it has that format that we wanted. So at chapter 1 is this list of lines. So these are all the lines in chapter 1. And then the next key is 2, and these are the lines in chapter 2. Okay. So the next thing we'd like to do, using the list you created above, now create a list containing the count of lines per chapter. Use this to calculate the average number of lines for chapter in the novel. So if we iterate over chapter lines, which we know is our dictionary, then if I print the result there, what we get is, even though it's a dictionary, a set of key value pairs, when we iterate over it, we only iterate over the keys. And this is because we can then use the key to access the corresponding value. So chapter lines X. So you can see this will just be the chapter number, but this should be the lines in that chapter. So we can use the length function on that to find out, well, how many lines are in that chapter. So if I run that there, we'll see chapter 1 has 81 lines, chapter 2 has 77 lines, and so on. And so important to remember, when we iterate over dictionaries, we just iterate over the keys, and then we can use those keys to access the values inside. And so what we'll do is we'll just find these lengths and store them in a new object, and that's what the code we're doing here is. So we're creating a new empty list where we're going to put those lengths when we find them. So for each chapter number, find the chapter lines, find the length of those chapters, and then append it to our new chapter line text. We can then take a summation over that list because it's a list of integers, and then divide by the length of the list to get the average number of lines. So we can see the novel has an average of 177 non-empty lines per chapter. So the last part here is we want to use the counts we've created above to create a line plot, which shows the total number of lines in each chapter in the novel. The function we're using here is from matplotlib, so which we've imported as plt, and it's the plot function. So if I show you plt.plot, then we need two arguments in this case. We'll have a list of x values and a list of corresponding y values. So if I pass a list of x values there, and then a list of corresponding y values, we get this line chart back at the end, which is just the x values and their corresponding. So we're giving the coordinates in a list of x values and a list of corresponding y values. So for our case then, the x values will need to be the chapter numbers, and the y values will need to be the number of lines in each chapter, which we already have in chapter line counts. So that's what we're doing here, is to get those x values, we want the list of chapter numbers. There's a couple of different ways that we can do that. For one, they are stored in, if we take chapter lines, they're stored in the keys of chapter lines. So chapter lines keys will give us, these are the list of chapter numbers. Equally, we can use the range function, which is what's been used in the solution. So to show you a bit about range, we just pass the range with 10, for example, gives us this range object from 0 to 10. If I convert that to a list, then what we get back is a list from 0 up to 9. So it's starting at 0 and excluding the argument. If I give a second argument there, I can specify a new start for my range. So now I'm starting at 1. So in this case, we want a list of a range starting from 1 and going to the current chapter number plus 1. And that'll give us my chapter numbers. And then we already have the chapter line counts. The rest of this is kind of code for adding labels to that plot and kind of formatting the plot nicely. And so if I run that here, we can see the x values are the chapter numbers and the y values are the number of lines in each chapter. I'm not going to go through the bonus task now in the interest of time, but it's a case of taking the code that we've already written and reusing it on the other tests. So we'll look at second sheet now. Okay, so again, we're going to import some packages. One to note here is we're using counter objects. I'll show you that in a moment. But then defining the path is the same as before, and reading the file is much the same as before. In the last case, we used we split the file after we read it into lines. Now we just like to keep it as a single piece. So here you can see we're reading the full text of the file into a single string called full text, which has 700,000 characters. And then we can convert that to lowercase using the .lower method on strings. So if we take a quick look at the full text object, it is a single string with all the text in the book in lowercase. So we'd like to split that single string up into words. And again, the way we've done this is using regular expressions. If you like, I can hop back in here and quickly show you the way that regular expression works. So the regular expression we've chosen here is this \W, which refers to any character that is not a word, so alphanumeric or underscore. So what you can see here is now we've matched any white space or syntax in the text, but in some cases we've matched sort of the two separate kind of pieces of white space or syntax have been matched separately. So we can use the plus as we did before, and that's going to group everything in between each word in the text. And essentially this is what we'd like to split on, and that's why we've used this syntax here. So we define the pattern the same way we defined it before, using the re.compile. And then we can split the text using this split. So instead of looking for a match in the text and taking that match, we'd instead like to split the text every time we have a match. So if we take a look then at that all words object, so we're splitting the text and storing it in all words. We now have a list of every word in the text. Yeah. So now we'd like to filter out any words from the list which contain fewer than 2 characters or symbols. What we're doing here is we're iterating over a list of words. We're checking the length of the list and if the length of the word, and if the word has more than 2 or more characters, then we'll append it to a new empty list called keep words. So in this way, we create a list of words to keep, and then we can use the len functions on the words that we've kept and the words that we started with to find out how many words did we remove and how many words did we keep. So this is just iterating over a list and checking the length of the objects, similar to what we have in the worksheet. And then we're just using len operations. The last part, or the next part here, sorry, is working with sets. So the question is report the number of unique words that appear in the list of remaining words. So just quickly on sets, if I have a list of 1, 2, 3, 4, I'll put a duplicate in there, 5. Then that list is 1, 2, 3, 4, 4, 5. And if I convert it to a set, then you'll see we've got the curly braces here because it's a set, and the duplicates have been removed. So we can use the exact same approach to get the unique words in the text. So we're converting the list of keep words into a set. So we're getting only the unique words, and we're calling that unique words, and then we can check the length of the unique words. So now we see the text has 120,000 words, but there are only 6,000 of those words that are unique. And the next part is we're going to count the occurrence of words in the text, and we do that using this counter object. So just a moment. So we are converting the keep words, which is just a list of all the words we'd like to keep, into a counter object. And this is counter from the collections package, which we imported at the beginning. And that'll give us this word frequency. So if we look at word frequencies, we'll see that it's a dictionary type object. It's a list of key value pairs, but all the values are counts. So this is how often the word chapter occurred in the list that we passed before. So how often was this object found in that list? It was 61 times. This makes sense because we've got 61 chapters, as we saw before. This is a lot like a dictionary. It's a set of key value pairs, but because each one refers to a count, we can do some kind of extra things with it. So for example, we'd like to print the top 20 most common words in the novel. So if we take word frequencies again, and we use this most common, and we'll say the 20. So these are the 20 most common words that we had before. So we can see what we have is a list of tuples. So a list because we've got the square braces, and then normal parentheses is a tuple. So I can iterate over these. So for x in, we'll print the type. Okay. So we'll print the type of x. So you can see it's a list of tuples. And so if I take that out, we've got the occurred 4,000 times. I can actually unpack these separately. So I could refer to the first term there, which is the word, and then I could refer to the second term there, which is the count. But I could also unpack these at the time that I iterate over it. So I know that the first item in each tuple is the word, and the second item in each tuple is the count. So that's how we're going to do it. So then I can print the word and the count, and it's the same. So that's the syntax that we're using down here for word and count in word frequency. And then this is just for formatting a string. So saying we're first going to have an integer, and then, or sorry, we're first going to, we'll have an integer, and then we'll have a string and have them separated by a tab. The integer should be count, and the string should be. So if we run that here, we can see the 20 most common words in the novel are the, to, of, and her. So this isn't particularly useful because we have a lot of stop words in here. So that's what the next part. given this list of stop words, we'd like to remove these from the text and then kind of recount. We could remove them from the text and then count again, but instead what we can do is we can remove them from the counter object. So I'll define my list of stop words. And then if I take my word frequencies counter, and it's a kind of a set of key value pairs, so I can access the value at the key the, and this is the count of the word the. If I want to remove this from my word frequencies, I can use this del operator. So del word frequencies the, and now when I try to do the same lookup on word frequencies, we'll see it's 0. So it's been removed. So what I'd like to do is iterate over all of my stop words, and then using that del, just remove that stop word, and that's what we're doing here. So for stop word in stop words, just delete that stop word from word frequencies, and then we're just going to ask for the most common again. This is the same code as we used earlier. So now we've removed some of the stop words, and maybe these most common words are a little more informative, but there's still maybe some words that could be. The next part is to visualize the frequencies of the top 20 words using a horizontal bar chart. The bar chart works similarly to the line plot. So if you, this is the function that we're going to use here. So plot bar h. So what we're giving are, in the same way before we passed a list of x values and a list of y values, now we're going to pass a list of words and their frequencies, as in these are the bars and these are how tall they should be. So first we need that list of words and that list of frequencies, and we're going to do that by iterating over this most common result again, and we're going to collect a list of the top words and a list of their frequencies. So for word frequency in this list, unpack the words into this top words list and unpack the frequencies into this top frequency. And then we'd like the bar chart to be ordered from left to right, or from top to bottom. And that's the reason that these have been reversed. If I comment out these lines, then, and we run it again, then we see the most common word is at the bottom, the least common word is at the top. So that's the reason for reversing the list and then plotting. And again, we've just got, some additional code to label the figure and to create the figure with the right size. And then finally, we're using much of the same code again to remove some additional stop words and regenerate the bar chart. So here's just some more stop words that the students could consider. And then this is using the exact same code as before to remove those and to regenerate the bar plot. And for the last task here, we are comparing word frequencies in the full text, so across using Dracula and Frankenstein. So really, it's just taking the same code that we've written before and wrapping it up in some functions so that it can be applied in each case. So we're defining a path for Dracula and a path for Frankenstein, and then we're writing a function to load that text into a single string for each book. So I'll run these. And then we're just loading each of the texts into a string, and then we're writing a function which will find the top 30 words. This is again using the same code that we've written before. This is the same code just wrapped in a single function. And this will allow us to compare the top 30 most common words in the different books, so Dracula and Frankenstein. The last part here is from the top 30 word list, identify the top words common to both novels, the top words unique to Dracula, and the top words unique to Frankenstein. We can do this using sets. So if we look at top Dracula, then this is a list of the most common words in Dracula. So if we convert this to a set, we'll get the same information just stored in a set. And the reason we're storing them in sets is because they have the nice definition of intersection and difference. So to find the intersection will tell us terms which are common in both the sets, and the difference will tell us terms which are in Dracula but not in Frankenstein, and similarly in Frankenstein and not in Okay, and I'll move on to the last notebook, which is working with dictionaries and the metadata. So we're using the same imports, except now we're working with JSON, so we need to import this JSON. And we're setting up the file paths as before. We're going to read the file in much the same way, except if I'll just quickly open one of the JSON files for a look. So if we look at the metadata here, we can see it's not just a simple text file, it's a JSON file, which means it has this sort of structure. So we don't want to just read it as a single string. We'd like to load it into a JSON object, or we'd like to load it from a JSON object into a Python object. So if I run this here, and then we look at novel metadata, now we have a dictionary. Okay, and so there's a structure to this. We have two keys in our dictionary, author and novel. And so if we look in author, we can see that within author, there's a second dictionary which contains metadata about the author. And in novel, we have much the same metadata about the novel. So we could use this information to answer some more questions. So to parse the novel title and publication year, we're just looking in that novel, which is a nested dictionary. We'd like to query the title. Again, in the same novel nested dictionary, we'll query the year. And then from the author information, we can query the first name and the surname. And so in addition to the metadata text, we also have a characters JSON file, which contains each character. And for an example, for a particular character, they have a list of aliases and a list of attributes. So let's move back in here. So we're going to use the same code as we've seen before to read the characters into a JSON object, or into a Python dictionary. And then if we take a look at characters, so here again we can see we've got a dictionary with each character. They have a set of aliases and a set of attributes, or a list of aliases and a list of attributes. So how many characters have been identified in the novel? This is the length of that characters dictionary, because each key refers to a different character. So there's 122 characters in the novel. And the definitive name for the characters is the name that's not an alias. So it's the name given as the key. So we can just print the list of keys for the dictionary. And we can see here there's this long list of keys for the dictionary. And then to display the aliases provided for a single character, the protagonist of the novel, Elizabeth Bennet. So if we look at the characters, then we can see this refers to, it's a dictionary with two keys, aliases and attributes. And if we look within aliases, then we have a list of the aliases used for Elizabeth Bennet in the text. And the same for attributes. Okay, so yeah, just some lookups on dictionaries again. Elizabeth Bennet has these aliases and these attributes. Okay, we're moving on to counting character attributes. So if we iterate over our dictionary of characters, then for each character, we get their name. And we can look up for a given character. Let's take a young Lucas. Again, we can see that in characters, we have, for any given character, we have aliases and attributes. So what we'd like to do is iterate over every character, access their attributes, and then check and then, sorry, we want to keep a record of these different attributes and see how often they occur for each character. So count the number of characters, or we're starting with male. Thank you. So we're going to look at the attributes on characters, and we'd like to check if the character has the male attribute, we'll increase the count for male, and if the character has the female attribute, we'll increase the count. So we'll create two counters, female count and male count, and then for each character in the text, we're going to access that character. And then we'll access their list of attributes, and we'll use the in operator to check if the string in is contained within that list of attributes. If it is, that character has the female attribute, and we'll increase the female count by 1. And if they have the male attribute, we'll increase the male count. And we can see 52 female characters and 59 male. So we want to count the number of times that each character attribute appears in the dictionary. So instead of just counting how often a character female occurs or male occurs, we'd like to do the same for every character attribute. And again, we'll use a counter as we have before. So for each character in the list of characters, we'll access that character and their metadata. And then for each attribute in that character's attributes, we would like to increase the count for that attribute in our counter. Okay, so we have a count. And this counts object which is a counter, and at the key for that particular attribute, we'd like to increase the count by 1. And then we'll use the same code as we had before for checking the most common words. And so you can see again those same counts for female and male come out, but we can see other really common attributes. And then we're going to create a bar chart which visualizes the attribute counts for the following. So now we'd like to access the counts for each of these attributes and then put that in a bar chart. So the first thing we need to do is we need a list of the counts to go with each of these words. So we're going to iterate over this list of required attributes. We're going to look up the count for that attribute, and we're going to store that in our required counts. And then we will have a list of required attributes and the counts which correspond to those attributes, and we'll use that. And so again, we're passing the list of attributes, so what our bars should be, and then how tall those bars should be. And then we're setting colors and so on. I think that's all from me.